How does the strength of electrical force change with distance?
Write that question in your composition book and try to answer it.
In this video, we are going to investigate Coulomb's law. Coulomb's law can be stated as following. The electrical force exerted between two charged objects is directly proportional to the size of the charges and inversely proportional to the square of the distance between them. To understand Coulomb's law, we must understand what is meant by electrical force. Electrical force is the repulsive or attractive interaction that occurs between two charged particles. If the charges are both positive, as shown here and here, the force will be repulsive, meaning the particles will move away from each other. If the charges are opposite, as shown here and here, the force will be attractive, meaning the particles will move toward each other. Electrical force is measured with an electroscope. When dealing with electrical force, charges can be either positive or negative. Electrical force is calculated using Coulomb's law, as shown in the box below. F is equal to Ke times Q1 times Q2 divided by d squared. Q1 and Q2 are the quantities of electrical charge on each of the objects. D is the distance between the two objects. We will not use this value of K. Rather, we will use Coulomb's constant being 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. The unit for electrical charge is the Coulomb as defined here. The elementary charge is the charge on a proton and the charge on an electron, as shown here. If it is a proton, this value will be positive. If it is an electron, it will be negative.
Now let's practice using Coulomb's law. Write down this example in your composition book and then we'll work it together.
First, let's write what we know. We know Coulomb's constant is 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. We know the distance between the charges is 5.29 times 10 to the negative 11 meters. We know the value of Q1, because it says it's a proton, is 1.6 times 10 to the minus 19 coulombs. We know the value of Q2, since it's an electron, is negative 1.6 times 10 to the minus 19 coulombs. And we will use Coulomb's law, F equals K Q1 Q2 over d squared, to find the value of the electrical force. Now we plug in all of the values that we know, starting with K, and next our values for our charges. Running out of room, so I'm going to move it over just a little bit, and ending with our distance. And don't forget to square that. Now put all of those values in your calculator. You should get a value of the electrical force to be negative 8.2 times 10 to the negative 8 newtons. And this would be the value of the electrical force between a proton and an electron in a hydrogen atom. The fact that it is negative indicates to me that this is an attractive force because these two charges were oppositely charged.